In section 5.3, we're going to discuss area and various formulas that we can use to find areas. For this lesson, we want to understand what is the concept of area and how do we use formulas for area to find the area of different polygons. It's important that you realize as we are using formulas throughout this section that we use the letter H to represent the height of a figure. We also call that the altitude, and those are always perpendicular to the base or they make a 90-degree angle. That's what perpendicular means. So if I had a triangle, then this dotted line would be my height or my altitude because it has to be perpendicular to the base. So here are some formulas that we're going to be using to find area. So make sure that you are familiar with those and that you have them in your notes. In example 1, we're going to be finding the area of a triangle. Well, the area of a triangle is 1/2 base times height. So in this picture, my base is 10 and my height is 4, so that when I multiply that together with my calculator, I'm going to get 20, and my units for area is always square units. So square inches, square feet, so they'll be square units. So that would be 20 square inches for the area. In example 2, we're going to find the area of a trapezoid. So our formula for the area of a trapezoid is 1/2 H B1 plus B2. Now that's not exactly the same as the formula that you saw on a previous slide, but this is the normal formula that you would see for trapezoids. The B1 and the B2 are the two bases, and they're going to be the parallel sides. So for this trapezoid, we're going to have 1/2, the height is 6, and then my bases are the two parallel sides, and they're 12 plus 24. And then we'll grab our calculator. Be careful and make sure that this 12 plus 24 is included with parentheses in your calculator, or you will get the wrong answer. So then if I put this into my calculator, I'm going to see that I should get 108. And if you don't, go back and try working with parentheses until you can get the calculator to give you 108. And that would be square inches. In example 3, we're going to find the area of a composite figure. And by composite figure, we just mean that it is a shape made up of other shapes. So if you'll notice here, we have a triangle sitting on top of a rectangle with another triangle on the side. So that's made up of 3 different shapes. The easiest way to find this area is to find the area of each shape. So for shape 1, the triangle, we use area equals 1/2 base times height. My base for that triangle will be 3, and I get that from right here, which would also have to be the same distance as the 3 across the bottom. And my height for triangle 1 is 2. So if I multiply that together, I'm going to get 3. For shape number 2, that's the rectangle, and its area is length times width. So that'll just be 2 times 3, which is 6. And then for shape 3, we have another triangle, and that's 1/2 base times height. But for this triangle, the base is going to be right here, which would be the same distance as that. So that's going to be 2 times the height, which is 1. And if I multiply that together, I'm going to get 1. Now I add up those 3 shapes, 3 plus 6 plus 1, and I get 10, and then my units on that would be square centimeters. Example 4 asks us to find the area that's been cut out of a rectangle. So what we're looking for is this shaded area. So I'm going to think of this as a rectangle minus a square. Well, my formula for a rectangle is length times width. And the square is side times side, or side squared. So the length is 30 times the width is 25 minus, and then it would be 10 times 10, or 10 squared. 30 times 25 gives me 750, and 10 times 10, or 10 squared, is 100. So when I subtract, I get 650 square feet. Example 5 asked me to find the area of this polygon, and there's actually multiple ways to solve this. The first way that I would solve this, and I think it's the easiest, is to think of this as one big rectangle missing this little rectangle here. So I'm going to do this as rectangle 1, the big rectangle, minus rectangle 2. Well, rectangle 1 is this, an 8 by 12, length times width. And rectangle 2 is a 5 by 4. So that's length times width. 8 times 12 gives me 96, and 5 times 4 gives me 20. But now I subtract those, and I get 76 square inches. So that, to me, is the easiest way to do it, but I do want to show you some other ways that you can solve this problem. So let's look at one way that you can do it that involves addition. So what I want to do there is then divide this shape up into multiple shapes. So one way I can do that is to think of drawing a line across the bottom. And when I do that, I'm going to get 3 different rectangles. And I've got to find the area of each one of those, and then I'll add it together. So I think this is a little more difficult. Some people prefer this. So let's look at some measurements that aren't given to me that I'm going to need to know. So for rectangle 1, I know that it's 2 by whatever that distance is. Well, that's going to have to be the same as that 5 that I have over with rectangle 3. So rectangle 1 is a 2 by 5, which makes it 10. Now, rectangle 2, I need to know this distance. So to do that, I have to think, well, that whole thing is 8. And we now know this top part is 5. So that's going to leave this little part here to be 3. So that rectangle 2 is a 3 by 12, which is 36. And then rectangle 3 is actually the easiest one to find because you know the length and the width. It's a 5 by 6, which is 30. And now if I add all that together, I get 76 square inches. Notice that both of those do give you the same answer. There is one other way you can do this, and I'm not going to do it, but I will just show you another way you could have divided this up using addition. So then rather than cut everything horizontally, what I could have done was I could have cut vertically and divided it up into those rectangles and gotten 3. Also could have done both horizontally and vertically and gotten 5 rectangles and found the area of all of those and added them together. All of them will give you an answer of 76 square inches. In our final example, we're going to do another word problem. It tells me that a baseball infield is in the shape of a square that's 90 feet on each side. So imagine that here is my shape. There's home, first, second, third. We know that each measurement is 90 on a side. 90 feet. So I want to know, A, what's the perimeter? So since this is a square, remember that our formula for perimeter is 4 times S. So that's going to be 4 times 90, which will be 360, and my units on this were feet. So perimeter has linear units. They're just feet, yards, miles. And then B is what is the area of the infield? Well, the area of a square is side squared, or side times side. So that's going to be 90 squared, which is 8,100, but area is square units, so it's going to be square feet. Now what I would like you to do is to turn to page 186 in your book and work on problems 4 through 8 and number 10. Have those completed for the next session. We will go over the answers to those and answer any questions you may have about either those problems or the video. So please make sure you mark any questions that you want to ask at the beginning of class.